Today, we are going to talk about one of the most fascinating and mysterious phenomena in the universe, the formation of black holes. These are some of the most enigmatic objects in the cosmos, and their formation has puzzled astronomers for decades. To start with, let's understand what black holes are. A black hole is an area in space where the gravitational pull is so strong that nothing, not even light, can escape. It is formed when a massive star collapses under the force of its own gravity, creating a singularity, a point of infinite density and gravity, surrounded by an event horizon, which marks the point of no return for anything that falls into the black hole. The Milky Way could contain over 100 million black holes, though detecting these gluttonous beasts is very difficult. At the heart of the Milky Way lies a supermassive black hole, Sagittarius A. The colossal structure is about 4 million times the mass of the Sun and lies approximately 26,000 light-years away from Earth, according to a statement from NASA. Now let's talk about how the black holes form. The process is complex and involves a sequence of events. It begins with the birth of a massive star, which has a mass greater than 20 times that of the Sun. Such a star is much larger and hotter than our Sun, and its core is a furnace of nuclear fusion reactions that release massive amounts of energy. As the star consumes its fuel, it begins to run out of lighter elements to fuse, and the core starts to contract under its own gravity. This contraction causes the core temperature to rise until the remaining elements, such as iron, can no longer sustain fusion reactions. At this point, the core collapses inward, creating a shockwave that blasts the outer layers of the star into space in a massive explosion called a supernova. The remaining core, which is now highly compressed, continues to collapse until it reaches a point where the gravitational force is so strong that not even light can escape. This is the birth of a black hole. The mass of the collapsing core determines the size of the resulting black hole. For example, a core with a mass of about 3 times that of the Sun will create a black hole with a mass of about 3 solar masses. Similarly, a core with a mass of about 25 times that of the Sun will create a black hole with a mass of about 25 solar masses. Albert Einstein first predicted the existence of black holes in 1916, with his general theory of relativity. The term black hole was coined many years later in 1967 by American astronomer John Wheeler after decades of black holes being known only as theoretical objects. Black holes have 3 layers, the outer and inner event horizon, and the singularity. The event horizon of a black hole is the boundary around the mouth of the black hole, past which light cannot escape. Once a particle crosses the event horizon, it cannot leave. Gravity is constant across the event horizon. The inner region of a black hole, where the object's mass lies, is known as its singularity, the single point in spacetime where the mass of the black hole is concentrated. Scientists can't see black holes the way they can see stars and other objects in space. Instead, astronomers must rely on detecting the radiation black holes emit as dust and gas are drawn into the dense creatures. But supermassive black holes, lying in the center of a galaxy, may become shrouded by the thick dust and gas around them, which can block the telltale emissions. Sometimes, as matter is drawn toward a black hole, it ricochets off the event horizon and is hurled outward, rather than being tugged into the maw. Bright jets of material traveling at near relativistic speeds are created. Although the black hole remains unseen, these powerful jets can be viewed from great distances. Recent studies have also shown that black holes may form through mergers of smaller black holes. When 2 black holes come together, they merge to form a single, more massive black hole. This process is known as a black hole merger and can release vast amounts of gravitational waves, ripples in the fabric of spacetime that can be detected by gravitational wave observatories like LIGO and Virgo. Black hole mergers have led to some interesting findings. Scientists have discovered that the largest black holes are not necessarily the oldest. Some of the most massive black holes in the universe have been found in very young galaxies, which suggests that they may have formed through mergers of smaller black holes in a relatively short amount of time. However, one fascinating aspect of black hole formation is the role that dark matter may play. Dark matter is a mysterious substance that is thought to make up about 85% of the matter in the universe, but its nature is still unknown. Some scientists have proposed that dark matter may form black holes, either directly or indirectly, by influencing the formation of massive stars. The study of black holes and their formation is still ongoing, and new discoveries are being made all the time. It is a fascinating and mysterious field that continues to capture the imagination of scientists and the public alike. I hope this video has helped you to understand a little more about the incredible world of black holes. Thank you.